Chapter 7. Transposition. This chapter covers root and columnar transposition, random number transposition, key transposition, multiple anagramming. In chapters 5 and 6 we looked at substitution ciphers. The second major category of secret key encryption methods is transposition. Transposition means changing the order of elements in the message. These elements may be words, syllables, letters, or the individual digits or bits that represent the letters. In this chapter we will deal primarily with letter transposition, but keep in mind that you can use the same methods for other elements, such as word transposition, in section 7.2.2. This chapter will cover many different types of transposition ciphers. You can do most of these transposition ciphers using only pencil and paper. Section 7.1. Root transposition. Root transposition is the simplest and oldest form of transposition cipher. There is no key involved. The secrecy comes from the choice of routes or paths. Root transposition is a great way to get children interested in cryptography. It makes a great activity for classrooms, scout troops, and other clubs. The main caveat is that the children must write the letters uniformly in straight columns, otherwise the message gets garbled. This can be avoided by using graph paper with wide spacing. The basic idea is that the message is written into a rectangle using one root, and then read out using a different root. For example, if the message has 30 characters, then a 5 times 6 rectangle is best. If the message has 29 characters, just add a null. Pad the message with nulls until it fits into a rectangle of suitable size. It is helpful to draw the outline of the rectangle before you start to fill it in. If the message is long, break it into blocks of a convenient size. For example, a message of 1000 characters might be broken into 20 5 times 10 blocks. We have already seen one example of a root transposition in section 4.3. The message was written into the 5 by 5 grid horizontally from left to right across the rows, and read out vertically top to bottom down the columns. Horizontal and vertical are two types of roots. Here is a fuller list. Horizontally left to right, right to left, or alternating left and right. Vertically top to bottom, bottom to top, or alternating up and down. Diagonally upper left to lower right, lower left to upper right, and so forth, or alternating. Spiral from any corner inward or from the center outward, clockwise or counterclockwise. You can start in any corner of the rectangle, use any route to write the message in, and use any other route to read the message out. Here is an example of a fancy route. The message would be written into the grid in the order indicated by the numbers, and read out by columns, that is 1, 36, 37, 39, 42, 2, 6, 38. For a root transposition, Emily only needs to guess the route you used to read the message out. After Emily has filled the message into the rectangle, it can be read by inspection. Note that it does not matter to Emily whether you wrote the message horizontally into the 5 by 6 rectangle or vertically into the 6 by 5 rectangle. Neither does it matter whether you started at the top row and worked down or the bottom row and worked up. Emily cannot tell the difference. Root transposition is rated 1. Section 7.2. Columnar transposition. Columnar transposition is the workhorse of transposition ciphers. It has been used by armies, diplomats, and spies since the 17th century. The method is first described in a 1685 book by John Falconer, Cryptomnesis Parte Facta. Secret communication revealed. After the Glorious Revolution of 1688, John Falconer followed James II into exile in France, where he died before the second edition of the book was published in 1692, under the new title, Rules for Explaining and Deciphering All Manner of Secret Writing. Columnar transposition uses a key that may be a string of consecutive numbers in mixed order, or a keyword or key phrase that gets turned into a numeric string by numbering the letters in alphabetic order. Consider the keyword sample. The letter A comes earliest in alphabetical order, so it gets numbered 1. Next in alphabetic order is E, which gets numbered 2. Then L, M, P and S. So sample gets converted into the string 6145332. If the same letter appears more than once, the occurrences are numbered from left to right. For example, anaconda becomes 1624873. Write the message into a grid horizontally from left to right. The number of columns is the size of the key. If the key is sample, there are 6 columns. If the key is anaconda, there are 8 columns. Write the numeric key above the grid, like this. Read the message out vertically top to bottom, according to the numeric key, starting with the column numbered 1, E, K, F, H, E, then column 2, E, S, R, A, T, column 3, N, R, O, W, through column 8, Y, C, Y, I, as shown. Reaver, the legitimate receiver, needs to do a little arithmetic to read the message. The key length is 8 letters, and the message length is 35 letters. 35 divided by 8 is 4, with a remainder of 3. That means that the array will contain 4 complete rows of 8 letters, plus a short row of 3 letters. Reaver should draw the outline of this array before she starts filling in the columns, so that she places the correct number of characters in each. The task for Emily, the enemy, is a little harder. The technique is to write the letters from each column vertically onto a strip of paper, and then match up those strips to determine the order of the columns. She looks for pairs of strips where the matching letters form common bigrams. When she gets a good match, she tries to add a third strip either before or after those 2 strips. Once 3 or 4 strips are correctly matched, short words begin to appear, and the task becomes easy. Emily does not know the length of the keyword, so she needs to guess it. She might start at 5 and work up. Let's suppose she has gotten up to 8, the correct length. Like Reaver, she divides 35 by 8. She knows that there are 5 short columns of 4 letters each, and 3 long columns of 5 letters each. Emily's problem is where to start and end each strip, so that it contains at least 1 full column. The first strip starts at the first character of the ciphertext, and must be 5 letters long, in case the first column read out of the array was a long one. The second strip starts at the 5th letter of the ciphertext, in case the first column was short, and ends at the 10th letter, in case both the first and second columns were short. Similarly for the 3rd and 4th strips. Then Emily will do the opposite for the other 4 strips, working from the last letter of the ciphertext backward toward the centre. Emily will then match up the strips, sliding them against one another to determine the correct alignments. All of this is done by eye, so Emily must know the frequencies of the most common bigrams and trigrams by heart. This can also be done by computer in a simple, straightforward way. The most common countermeasure to this type of matching procedure is for Sandra, the sender, to read out some of the columns from top to bottom, and some of them from bottom to top. This means that Emily will need a second set of strips, reading backward. She will then have twice as many strips to attempt to match up. With all columns reading down, columnar transposition is rated 2 if the array is a rectangle, and 3 if it is not. With columns reading in alternating directions, Columnar transposition is rated 3 if the grid is a rectangle, or if the columns are long, and 4 otherwise. Columnar transposition is a tried and true method for adding strength to any type of substitution cipher. Columnar transposition, combined with a well-mixed keyed simple substitution, is rated 5. When combined with a well-mixed general polyalphabetic cipher, it is rated 7. The combination is strongest if the lengths of the two keys are co-prime.